Directional property of magnets. Now, magnets have a tendency to respond to the Earth's magnetic field. This property is useful in determining the poles of a magnet. In order to determine the directional property of magnets in the laboratory, we need a magnet with unknown poles. So the magnet is tied with a thread and suspended using a string. The magnet is then allowed to settle and attain the equilibrium position. Equilibrium position in this case is the point at which the magnet is balanced. The thread or the string should be tied in such a way that it is perpendicular to the magnetic axis. Magnetic axis is an imaginary line through the poles of a magnet. The magnet is then allowed to settle freely. And observations made. In this case, the observation made is that the magnet settles in a compass north-south direction. A compass north-south direction. From this observation, we define the polarities of a magnet. The end pointing the north direction is the North Pole, or north-seeking pole. The other end pointing the south direction is the South Pole. Remember, the North Pole can also be called north-seeking pole, while the South Pole can also be called south-seeking pole. And these ends of the magnet points the compass north and south directions respectively. Polarity of a magnet. As demonstrated from the diagram and as stated earlier, a magnet has two poles. We have the North Pole which can also be called north-seeking pole, The North Pole is normally denoted by capital N. So when we see capital N in a magnet, then we know that we are referring to the North Pole of the magnet. The other pole is the South Pole or south-seeking pole. In diagrams, we commonly use the letter S to denote the south pole of a magnet. So a magnet generally has two poles, the North Pole and the South Pole.